Yay, we're live.
All right, hello everybody, and welcome to the 8th in our monthly installments of virtual astronomical outreach, brought to you from the Riverside Astronomical Society in collaboration with the Department of Physics and Astronomy at the University of California at Riverside. And tonight, we bring you our April Fool's edition. So don't be fooled. What we'll be looking at today are the myths, the misconceptions, and the mistakes that astronomers have made for the last couple thousand years. So we'll be addressing all of those. We'll be looking at 4 different objects through our telescopes. We'll be at 4 different areas of the sky. And we'll be showing you some pretty cool things. So if you can, watch us on a big screen, not just your phone or your tablet, ideally something maybe even hanging on your wall. But just do the best you can with the biggest screen you got, and I think you'll be happy with that. Sinan? Oh, yeah, well, no, wait, I haven't introduced myself.
I was about to say that.
I forgot. I'm sorry. I'm John Liederbach Vega, and I am the director for the outreach program at the Riverside Astronomical Society right here at Riverside. I'm coming to you from my home in the city of Riverside here in Southern California. I am not any sort of professionally trained astronomer. But I've been in love with the hobby and the science of astronomy ever since Neil Armstrong landed on the moon when I was just a young boy. Anyway, hopefully you'll enjoy tonight, and my co-host, Sinan.
Thanks, John, and good evening, everyone. My name's Sinan Du, and I am in charge of the public outreach program in the Department of Physics and Astronomy at UC Riverside. My professional background is astronomy, and specifically I study galaxies that are really, really far away from the Milky Way. And today we'll actually have a chance to look at one of those through a telescope. So we're very excited to continue this monthly stargazing program in collaboration with the Riverside Astronomical Society. And I especially like today's theme, April Fool, where we will be debunk a handful of myths in astronomy. So next, I will have our lovely volunteers to introduce themselves. As you can see, they will be moderating the live chat that you can find on the right-hand side of the YouTube website page. So Jess?
Hi, I'm Jess Stappel. I am a PhD candidate at the University of California, Riverside. I study globular clusters and galaxies and all that fun stuff, and I'm really excited to answer your questions tonight.
Thanks. Garrett?
Hello, everyone. My name is Garrett Lopez. I'm a second-year graduate student at the University of California, Riverside, and I study what intergalactic gas can tell us about dark matter.
Very cool. Thank you. And next we have Yongda.
Hello, everyone. My name is Yongda Zhu. I'm also a graduate student at UCR, and I'm studying the early universe, especially the epoch of reionization and the intergalactic media. So I'm very happy to be here to answer your questions.
Thank you. Next, we have Mingfeng.
Hello, everyone. I'm Mingfeng. I'm a third-year PhD student in UCR, and I study using simulation to do the cosmic inference in our cosmology, and that's all.
Thank you. And Amanda?
Hi, everyone. My name is Amanda. I'm also a graduate student at UC Riverside, and I study very, very massive galaxy clusters and see what they can tell us about how space bends around them.
Great. Franco?
Hi there, my name is Franco Iglesias. I'm a first-year grad student at CSULA, and I'm pursuing my master's degree in physics. I'm happy to be here.
Thanks. And last, we have Cheryl.
Hi, I am Cheryl Wilcox. I am a middle school science teacher by day, and I am a proud member of the Riverside Astronomical Society, where I use my 8-inch Newtonian telescope when I can, other than tonight when it's kind of cloudy. So I'll be answering questions in the chat instead. Thanks, everybody.
Thank you all. So the other telescope operators will introduce themselves when it's their turns in the program. So we welcome all kinds of questions and comments, and also encourage you to engage in discussions. Please be respectful to everyone in the chat. Most of the questions will be answered by the chat moderators, and we will also have the remainder to be answered by everyone on the panel. So this is our 8th stargazing event, and we are really excited to see some of the newcomers and also welcome all those who have already participated in our previous events. We would certainly love to collect your feedback on how we did tonight, and also how we could improve our program next time based on your needs and preference. So finally, as a new format of our 2021 Stargazing program, you have a chance to enter the raffle at the end of the event. Our prize is a very beautiful NASA calendar provided by one of our NASA solar system ambassador. So John, would you like to showcase that calendar to everyone?
Yeah, it's pretty cool. Every page has got an amazing astrophoto photograph of different aspects. You know, so here we have the moon, we have Mars, we have deep space, and then there's a profile of a prominent astronomer and how their life has been and what their research is and how they've contributed to the science. So it's pretty cool. It's a nice, big, beautiful, colorful calendar, and it could be yours for free if you win our raffle.
Thank you, John. And what's more exciting is that we'll continue this kind of raffle throughout as long as this stargazing program is going to be. And upcoming, we will also raffle some astronomy books. And in June, when we are celebrating our virtual stargazing anniversary, we will be raffling a telescope. How exciting is that? All right, so now I am going to, before I go back, give it back to you, John, we've got some inquiries regarding why are we starting so late, you know, as we go into the summer?
I can answer that. There is a thing called daylight savings time. And even without daylight savings time, as you may notice, it's darker in the winter than it is in the summer. And we have to have darkness if we're going to be able to look up in our sky with telescopes and be able to see anything other than the brightest stuff up there. And like Sinan said, we're going to be going deep into space and looking at some distant galaxies tonight. And you really need to have a dark sky for that. So we have to wait for the sun to go down and then some before we start. And so next month, it'll even be later. I think we'll probably be starting more like 8:30 next month. So sorry about that, but we just have to wait till darkness.
Yeah, that's exactly right. Well, thanks, John. And I guess we can now start with our telescope viewing.
Yes. So I don't know if you realize this or not, but Mars has an advanced civilization on it with big industrial machinery that can do amazing things as they change the surface of their planet. At least that's what we were told once. Randy is going to take us to Mars and explore all about that. And you can actually see Mars just with your naked eye. If you go out tonight and look over in the western sky, you'll see a beautiful red star. And you wonder why it's called the red planet? Well, you can see it looks pretty red, or at least orange. So you don't need a telescope to see Mars, but Randy's going to take us there with his telescopes, etc. So Randy, take it away.
All right, let me see if I can get this thing going and get the PowerPoint thing going here. And go to sharing.
Here we go, Randy.
Is that the full page or is that a big mess?
We see just the top half of your screen, of your PowerPoint.
How's that? Is that better?
Nope.
Nope.
Still just half a screen visible. There we go. Oh, now it's gone.
Okay, this should do it. All righty. I'll start out with a few pictures here from the glorious 1950s of some pictures and probably one earlier than that about what they theorized Mars was on there. And this is kind of reference to the visual evidence of the time, which was the canals on Mars. The canals on Mars and also seasonal changes of certain areas, particularly around the equator, darkening and lightening. Have astronomers, for the classic astronomers, seen canals on Mars? Yes, this was sort of popularized this. Have observers seen them today? Yes, people still see them today. Have they been seen with modern equipment and techniques? Yes, but mostly no. So what's going on? Are there any canals or not? Well, you could try looking for yourself, and if you wanted to, you need to look to the west. You see this little W down here. This is Taurus the bull right here. You'll see two bright stars sort of about the same color here and lower down to the west. This is Aldebaran, the eye, the red eye of the bull, which actually kind of looks orangish, and Mars looks orangish. And so you'll see Betelgeuse, kind of an orangish red star way over here. Don't get these two confused, go for the upper one, and that is Mars. The problem with Mars is it's kind of far away right now. And what I'll do is I'm going to switch over, if I can here, to a semi-live image. In other words, I recorded it before the clouds came in, of Mars as it is right now. Okay. Can anybody see this?
Yes.
Okay, this is Mars as it appears right now. It actually looks visually smaller than Mercury and slightly bigger than the planet Uranus. And if you don't see much detail on here, it looks like a flashlight in the distance. Somebody's just is shaking in the distance. You would be right. That's about as good as it gets right now. So, well, why is this? Well, let me go to my next page. Let's switch back. Here we go. Here is a picture diagram of Earth and Mars. Here's the Earth, there's the sun. Way over here is Mars. That's currently, like right now at this time today. If you were to take pictures of Mars that was this big, this is how big Jupiter and Saturn and the other planets would be. You'll notice it's pretty tiny. You go back to, or during a close approach in October, Mars would look this big. So it's actually quite a bit larger than what you see right now. It's almost as large as Jupiter and bigger than the disk of Saturn. Why? It's because Earth and Mars are much, much closer. Mars is now 4.25 times farther away than it was. So in other words, Mars changes in size quite a bit as it comes in a close approach. We usually do not show Mars very often for outreaches because it's usually pretty small, and the seeing detail on it on Mars is very difficult. It's fuzzy, it's dim, it's well undefined, and we're even much smaller than this would be right here. And this is over a few months' time up to the close approach in 2018, and then as it goes away. So let's see what it kind of more looks like back then. And I need to switch over to see if I can get that movie going. This was recorded, I believe, about in August. And let's see here. Let me put this going. And can we see that one?
Yes.
You see that one's a little bit bigger. And I could try blowing it up a little bit. But you can at least see some shading. You can see some details. You see what looks like India and this arm that comes out over here, and a light patch, which is actually the second largest crater on a planet in the solar system called Hellas. And then the little tiny polar cap over here. And this is the darkening areas that change a bit with the seasons. So with that, and people seeing imaginary lines coming off some of these structures here, which they were saying are canals. I'm going to go one more. Let me stop this one and go to another video of a live view that I took captured in October. And let's go to this one. And can you see this one?
Yes. Beautiful.
Can you see both at the same time?
Yes.
All right. You saw how small Mars was at the beginning. This is quite a bit bigger, and this was just about at its best. It's also, this one is in color. And again, you can see the sort of the differences. Let me go on back to back to the other slide. And skip. When it first kind of got it started was a fellow by the name of Giovanni Schiaparelli, who was an Italian astronomer who was obviously in Italy and actually the director of the Milan Observatory there for quite a long time. And he saw these lines. This is one of his first maps of, or the maps during the close occultation, close approach of Mars. And these are the elements that he saw. He called them canali, which in Italian means channels. Unfortunately, a number of astronomers of his day mistranslated into canals. Canals implies intelligent origin. Giovanni was, hoping that it might be evidence of life, but he was not cited really either way. He knew that they could be channels, like naturally occurring channels of water, erosion, and that sort of thing. But it also could have been, this is a quote from him, which water and organic life can spread on the dry surface of Mars. Percival Lowell, an American astronomer, he was actually a businessman, author, mathematician, and he built a large refracting telescope up in Flagstaff, which you can take a tour to these days. He was more on the thought that these are evidence of intelligent life. So part of his quote is, as advanced but desperate culture had built canals to tap Mars's polar ice caps. And he wrote 3 books on it. General population at the time was very intrigued by it, just as we are today about life, happening on Mars. So they end up drawing, for example, you take their information and put it together and they draw a globe. This is their drawing versus reality. This is a Hubble Space Telescope picture. And there's this looking at the same areas on Mars. You might say, well, why do they see these lines and stuff? Stephen O'Mara, an avid astronomer and writer who has written for Sky and Telescope magazine and during this last approach, said, I am going to see the canals of Mars. He knew that it was more of an optical illusion type of thing or a trick on your mind, but he wanted to see it. And he did a lot of, research into it to see if he could see, use the similar types of equipment, similar magnifications to try to see them, the canals of Mars. He did. His part of what he said was, my brain was gathering data quickly, but not accurately. An impression of what my mind thought I should see rather than what was really there. There's 2 sort of, I'm not going to go into a lot of detail, but irradiation illusion, where if you have a dark region like here or here with the deserts on either side, you look at it, you can kind of see the detail, but if your eye kind of goes off to the side, it tends to thin out and actually start making like nodules along with it. So that's one effect. The other is future seeing. Illusionists use it. Your brain tries to, when it sees motion and it's trying to figure out what's going on, tries to jump ahead 1/10 of a second and actually manufacture information by predicting where an object is moving or which way. And it ends up putting in information that you are more biased to want to see rather than what is really there. Things like, for example, these little triangular points here. The eye is naturally, if it sees a triangular shape like this one here, will try to add a line or a point off the arrow as this is sort of like pointing in a direction, you'll sort of automatically fill in. So it was basically an illusion. What do we see today? Well, here is kind of a historical search, historical record of different kinds of qualities of seeing. And modern day stuff. This is by Orbiter, and this is by Hubble. Here you can see the Grand Canyon. You can see some of the volcanoes on Mars, where from Earth itself, it's pretty hard to see this kind of details. But there was an amateur astronomer out of Great Britain that you just saw his work, which he's getting almost, not quite an orbiter view, but getting almost Hubble type pictures with his amateur work. Of course, lately he's had access to some bigger observatories as well. So as far as intelligent life goes, well, doesn't look like there is, but perhaps on your next vacation, You can go to the Martin City on Canal, very exclusive. But bring your COVID-19 masks. They found out that the Martian dust has perchlorates in it. It's about 4% or something like that, which can cause cancer or mess with your endocrine system. Some of these cities that he drove, this is all 1950-ish kind of style, and they sort of was probably where George Jetson really lived instead of here. And of course, some locals that say, leave your bottled water and you can have your landers back. With that, I think I'll turn it back over to John, I guess.
All right. Yes. Okay. So I guess what I said at the beginning is not true. Mars does not have advanced civilizations. All right. Anyway, let's go to Sinan, because I think we have some questions for our audience to see if they can answer.
Yes, totally. So this is our trivia question number 1 of the day. I'm not sure whether all of you have heard of this term, planetary nebula, but just to make a guess, do you think it is associated with a planet? Or if that tier 1 is way too easy for you, we have another slightly more difficult one for you. What do you think is a planetary nebula? So put your answers in the chat. We will definitely take a look, and later we will have Minfeng to give out the answer. So now I believe we have Alex to present the myths of the North Star.
Yes. Alex, would you like me to show everybody where the North Star is?
No, I got it in my presentation.
All right.
And am I sharing my screen now?
You are. We see it big and beautiful.
Okay, great. You got several images on the screen. Right down here, you've got a live image of Polaris. That's actually what it looks like right now, and we'll talk about it in a little bit. Now, it's a very bad image tonight because the air is very disturbed. As a matter of fact, I'm a little late getting to the program because just 10-15 minutes before showtime, it was still cloudy here. I've got another picture here for you in the photos, and you can see a little bit better what it looked like the other night when we were practicing. But at any rate, hi everybody. I'm Alex. I'm from Moreno Valley, California, and tonight we're going to be looking at the North Star, Polaris, through my Celestron 9¼ inch Schmidt-Cassegrain telescope. To find Polaris, all we need to do is find the Big Dipper, which is right now in the spring over in the northeastern sky, find the pointer stars, and it points straight to the Big Dipper. Now, we all think we know about the North Star. Julius Caesar, the great Julius Caesar, is said by Shakespeare to have compared himself to the North Star because he was as constant as the North Star, of whose true fixed and resting quality there is no fellow in the firmament. Yeah, he wanted everybody to know that he was the greatest, the brightest. He stood forever still and immobile, strong and all that. And those lead us to some of the things that everybody thinks they know about the North Star. It's brighter. It's the brightest star in the sky. It's due north. It's a constant, always there for us, always for all places and all centuries. And it's a guide. Sailors on the sea and explorers on land have been able to use it to find their way around. But none of this is true. Let's look at some things we know. It's called Polaris because the pole of the Earth, this pole that the Earth spins around, is pointed to Polaris. And all the stars spin around it, which you can see in a long exposure photograph. All of the stars seem to circle right around Polaris. That's right there, Polaris. And there are lots of other cool things to know about Polaris. The light from Polaris left the star about 433 years ago, and it's been traveling to our eyeballs at, of course, the speed of light. It's a yellow supergiant star, about the same color as our sun, but it's about 5 times bigger than our sun. It's actually 3 stars, and you can see 2 of them down here in this picture. See this picture? And then see off to the side here? Now, the other night, we could actually see that very well, but tonight, the sky's got a little bit of clouds in it, and it's really nasty. You can see that's why Polaris itself is moving around so much and comes in different shapes with every exposure. Many stars are really double and triple stars. We're kind of unusual in that we're a single star out there. So it's not unusual for it to be a triple star. But one thing you should know is that each of those other 2 stars are both more massive than the sun. So Polaris is certainly an interesting star. But what about those myths? Polaris is not the brightest star. It's a 2nd magnitude star, maybe a little brighter, maybe a little dimmer, because it changes its brightness over a 4-day cycle. And 2nd magnitude, now that's pretty respectable, 2nd magnitude, it's up there. But as you can see from this long list of stars, of the 5,000 stars that we can see in the sky, Polaris is only number 50. So that's not all that bright. And if it were directly north, as I said earlier, it would be stable. And you can see right here in this picture that it too is moving around. There's a little circle to it. And that means that it's not exactly at the center of the north of the pole. As a matter of fact, it's now some 40 arc minutes away. As close as that is, it's still about further away from the pole than the width of the moon. Now, it too goes around the North Pole, just like everything, all the other stars go around the North Pole. It is moving closer to the pole, but the closest it'll ever get is a little less than half a degree, about the width of the moon, and that's on March 24th, 2100. Some of you may be around then, and you will see the North Star as close as it's ever been to the actual pole. Then it's going to move further away again. Oh, wait a minute, you say. It's moving towards the pole? Yep. It's moving. And if it's moving constant, that sure wasn't, it isn't constant. It isn't always there. Yeah, that's true. It doesn't move very fast, but in fact, it moves. It takes about 26,000 years to move around. Oh, we've got sleepy computer here. But you can see that in this diagram right here, right now it's pointing towards Polaris. But as the gyroscope slows down, as our spinning slows down through time, we describe a big oval around here. And stars as far away as Vega, and if you're familiar with where Vega is, that's pretty far away. They will someday, within the next 26,000 years, be our North Star. Back in the time of Jesus, there was no North Star. Back when the pyramids were being built, this star over here was the North Star. So it's not a constant. Yoo-hoo, let's go. There we go. While we're here in Southern California, incidentally, it's, remember I told you you could find it by going right here to the North Star? If we were to go down to, maybe a little bit above Panama, look how much further it's shrunk down. And if we get below the equator, we can't even see the North Star. So there's no way that Dora the Explorer heading up the Amazon could use the North Star to guide her exploration. And this question comes up often, so we'll talk about it. If Polaris is the North Star, then what is the South Star? Well, there isn't any. This is the area where Polaris, where the South Pole is. See how all the lines point to that center there? And you can see when I get rid of those lines that there aren't any stars around here. Now, of course, that will change over the next 26,000 years. And maybe one of these other stars will in fact be the South Star, and we won't have any North Star. And it's just that way. So what did we find out? Polaris is not the brightest star in the sky, not due north. It's not constant, and it's not a universal guide. However, we got to remember, it's still got a lot going for it, and it's still a pretty cool star to know. So thank you.
Thank you, Alex. Awesome. So what can we learn about planetary nebula? What are the answers?
Wait a second. You see my screen?
Yes.
Cool. So I have seen lots of good answers in the chat, and one of my favorites is the Planetary Nebula is a dying stars fart, which is pretty good from Duke. So I will talk about Planetary Nebula. So it's not physically associated with the planet. So most of you got it correct. But how did the Planetary Nebula got its name? So I will talk about it. So back to the 18th century, a British astronomer / music composer, William Herschel, found the first planetary nebula, the Saturn Nebula, which we know now that has nothing to do with the Saturn. So in the paper, he wrote, the Saturn Nebula as its planetary appearance is so remarkable that we can hardly suppose it to be a nebula. Its light is so uniform as well as vivid, and the diameter is so small and well-defined. So it got its name because it appeared to look like a planet. And you can see it does look like Saturn's ring, despite I think it looks like COVID. Anyway, then with slightly more advanced technology, here was the drawing from an American astronomer, Dr. Curtis, in early 20th century, using Lick Observatory, compared to the imagery from the Hubble Space Telescope in 1997. So you now see more complex structure inside the nebula. So it's not as uniform as early observations and does not look like a Saturn as much actually. And move on to another example here is the Cat's Eye Nebula, the first planetary nebula, which Herschel found the central star of it. So actually Herschel thinks this nebula is something related to a star's burst. And on the left, I also show the drawing from Dr. Curtis in early 20th century. So you can see there's a very distinct central star there, even back in the days. And on the right, I show the Hubble Space Telescope and Chandra's observation in 1995. So you can also see the central star with surrounded by hot gas. So what's the contemporary view about the planetary nebula? So the contemporary view is that there are the gas shells being expelled by an almost dead star. So you can think it's a far from a dying star. So a star like our sun will evolve to a red giant after burn out the hydrogen at the core. A red giant can be 100 and 1,000 times larger than the sun, as you can see in the image. At the end of the red giant, a red giant star will eject the shells of hot tenuous ionized gas. And these expanding ionized gas shells will be the planetary nebula we see today. And the leftover core of the star will become a white dwarf at the center. A white dwarf is the end of a low mass star's life. So it's very dense. In summary, planetary nebula is not physically associated with planets, but instead an end product of a dead star. That's all. I will return back to John, I think.
Yeah, thank you. Well done, Mingfeng. Okay, so 1,000 years ago, hundreds of years ago, there were astrologers and there were astronomers. Sometimes they were the same person. Now, astrologers, they like to study the sky and the stars and the movements of the sun and the planets because they thought those meant important things for humans in terms of what kind of fortune you'll have this year as a farmer, or whether or not we should go to war, or whether or not there's a king being born. The answers were in the stars if you only knew how to interpret them. And those were astrologers. And then there were astronomers. Astronomers also studied the stars because they want to know what's going on up there. What are these planets, things moving around, and how can we explain all this, and maybe even make predictions about when there's going to be an eclipse of the sun or the moon. But astronomy didn't often pay the bills, right? So if you were an astrologer, then the king might hire you to be able to provide answers to him. You'd be one of the king's counselors, and you'd get some money that way. So that would then fund your research in astronomy. So oftentimes astrology and astronomy kind of got confused for a little while, but they are very different things now. But let me show you something that we inherited somewhat from astrologers, and that is the idea of the ecliptic, or the signs of the zodiac. So you've probably heard of constellations like Sagittarius, Gemini, Leo, Capricorn, those kind of things. And those are famous constellations because they lay along a line called the ecliptic. And that's this, I don't know if you can see this orange line here. And that is the path through which the sun travels through the sky, the moon travels through the sky, all the planets follow that line. So very clearly, anybody who paid attention to the skies would see there's something special up there. There's a line along which things in our solar system travel. So that must be important. So if the sun was in Virgo when you were born, that meant you're going to have, you're going to have an excellent job growing grapes, or you'll never have a happy love relationship, whatever, because where the sun is along the ecliptic, that's important in predicting who you're going to be. But we know that's not true. That is one of the myths or misconceptions or mistakes of astrology/astronomy over the years. But it is important. The idea of the ecliptic, or I guess the zodiac, is an important one, because if you're looking for planets in the sky, that's where you have to look. So if you know what that line is, it'll help you understand whether it's that thing up there, that really bright guy, is that a star or is it a planet? If it's not along the line of the ecliptic, you know it cannot be a planet. But tonight, if you want to go outside, or tomorrow night or the next night after that, and you could look up there, you will be able to find some constellations that are pretty famous, and you can find them and learn them. So this first one, if you look pretty high in the sky, you will see this constellation of Leo. And Leo is a lion. And this is one of those few constellations, I think, in the sky that actually kind of look like what they're supposed to look like. So Leo has this backwards question mark, or the sickle. And that is something where you can actually look up and see it. You see this sort of backwards question mark, and that is the head and the mane of Leo the lion. And later on today, actually, there's a kind of interesting group of galaxies that Manny's going to talk to us about right over here by Leo. But that's a whole nother section we'll talk about later. But so if we go back up and we move farther along the ecliptic, oops. Hold on one second. And if we go climb farther up towards the zenith, I don't know if you can see that little green Z near the top of the screen. That's directly overhead, as high as you can look in the sky. And there you will see a couple of bright stars right next to each other. And that's the constellation Gemini, the brothers Castor and Pollux. And they were a mischievous group. They got into all kinds of trouble. Anyway, they wind up in the sky. And these two stars that are really nice and bright, those are their heads. And there you can see their bodies, their legs, their arms. And again, this is another constellation that once you see it, it does kind of look like what you're supposed to look like. It looks like a couple of people right next to each other. And then finally, another interesting constellation along the zodiac, or along the ecliptic, is Taurus the bull. And that's kind of important for us tonight, because remember at the beginning we were talking about Mars, and Randy was talking about Mars, which is right here in Taurus. The cool thing, and Randy was talking about that orange star, Aldebaran, which looks a lot like Mars because they both have the nice red color. That's one of the brighter stars in the sky, and it's on this V-shaped thing right here, which is the head of Taurus the bull. And that one red eye he's got, Aldebaran, he's furious. He's ready to go and charge after somebody. So he's got this red eye where he's angry. And that's Aldebaran. And you can find that along the ecliptic, and you'll find this V shape, which is actually a group of stars called the Hyades. And so tonight you can go and look more kind of in the west, and you'll find Taurus the bull Up near the top of the sky, you'll find Gemini twins, Castor and Pollux. And then way over more towards the eastern part of the sky, you'll find Leo the lion. So they may not be predicting your personality or your fortune in life by where the sun is up there in those constellations, but it's still kind of cool to be able to find them. So with that, I think we'll go check out the chat room and see what kind of questions have been coming in.
We actually do have a handful of really good questions. So first question from Zayana M. Is Mars in its late or early stages? I know it's billions of years old, but is it considered young or old in its lifetime? Randy, would you like to take that?
There we go. Whoops. Okay, I should be on now.
Yeah, you are.
Okay. It'd be considered an old planet, I suppose. The real lifetime of the age of a planet would be really dependent upon the age of the star, the home star, and how long it would last. But with that, regardless of that, it would really be kind of considered an older planet simply because the features on Mars are relatively old. Some of the features go back to its early times where it had a thicker atmosphere and shows signs of water, liquid water and erosion and even shorelines. And those haven't changed much since those times. So since it's not completely devoid of new features because there's weathering and there's things going on, but there isn't too much in the way of impacting anymore. There's not much of any geologic activity. There's some mudslides and that sort of thing and wind erosion. But for most part, the features are fairly old. So the planet would be considered an old planet, even though it's about the same age as the Earth. The Earth would look younger by comparison because everything is changing so much.
Great. And there's another Mars-related question from the 24-hour bookstore. Why is it that the craters and other spots, like it looks so light? Wouldn't a groove, dent, and an object have to deal more with shadows? Is there a reason it's able to reflect so much light?
Is that still with me?
Yes.
Oh, okay. Well, if I can, let me go back and just get a picture so that you can see what I'm talking about as I go. Let me see if I can share screen and pull up this picture here and share. Do we see anything?
Yeah, we see the Mars near and close approach.
Okay. This is, yeah, I'll go back to Damian Peach. He's this fantastic amateur astronomer. This is incredible. He does better stuff than most observatories do, and he's using some smaller telescopes on top of that. But we'll take this picture over here. Here's Mars, and it's, let's see here. Here's a nice bright spot, this large crater, which I had benched before, Hallis, and it looks bright. Well, you can remember craters, particularly large enough to be able to see from the Earth, they're got to be huge. They're not little dents like in the side of your car that you've been trying to take care of. And you're seeing it lit where you can see it with the sunlight.
Randy,
yes.
I think we might not be seeing what you're talking about. We just see the different sizes of Saturn over a period of months.
Yes, that's the
not Saturn, excuse me, Mars.
Mars, yeah. Can you see the pointer?
No.
That's the problem. Okay, we need to see a pointer. Let me see if I can do a mouse.
Maybe, if it's easier just to, explain verbally, we also have other questions there.
Okay. Well, anyways, these are newer features. They've been flattened out by this impact, and they also tend, since most of them are kind of low, this is actually a very large basin here. They tend to collect lighter materials that's wind blowing. And in general, not always specifically, the darker areas are more rocky, mountainous areas, and the brighter areas tend to be more flat, sandy, and sometimes sand dune areas. And Hellas would certainly qualify because would be a basin that's picking up some of this lighter material. And of course, that would be brighter and more reflective than the rocky area, such as these other areas over in the equator here that you can see, like that one that looks like India. And that ought to do it.
Thank you, Randy.
Great, thank you. And another question from Zayana, are the ice caps on Mars drinkable if they melted?
That's a really good question. I'm going to assume you mean, do they contain water by drinkable? So actually the ice caps on Mars, at least the very top layer, is made out of dry ice when it's frozen. So when summer comes around, it sublimates, which just means that it goes from a solid to a gas. It bypasses the liquid stage completely. And so what you have, at least the top layer of the ice cap, is dry ice and then carbon dioxide in gas form. And this has been kind of a point of contention between scientists over the last couple of decades, but we do think that there is water contained under the surface of the ice cap. So technically, yes, if there is water, and maybe this is not a very satisfying answer because we don't know for sure, but we think that there is some water ice, and if you melt it, some scientists say that you would actually fill up Mars a couple of feet deep. So not a ton of water, but there will be some water to drink, at least the surface area of Mars a couple of feet deep. So you'll have plenty to drink, if that theory is true. But primarily it is made of, the top surface layer is made out of carbon dioxide. Just can't drink that.
Thank you, Amanda. That's really fun. Great. Okay, so John, should we now go to our story time?
Ooh, if you've been following us for the last few months, you know that we tell stories here. So we have a story about astronomy and some of the things that got screwed up over the years. So in the early days of astronomy, there were no telescopes. For 1,000 years or more, astronomers did the best they could just with their naked eyes. Then in 1608, a Dutch lens maker by the name of Hans Lippershey lined up two lenses, one in front of the other, and was amazed at what he was able to see. However, he never bothered to look up into the sky with his invention. Rather, he saw the telescope as a weapon of war. This would allow military commanders to spy on their enemies from a great distance.
Soon, word of this amazing new invention spread across Europe and into the ears of an Italian astronomer, physicist, and engineer by the name of Galileo Galilei. Before a year had passed, Galileo had created his own telescope, improving upon the design of Lippershey. And he wasted no time to use his telescope to gaze into the heavens. And the world would never be the same.
Now, back in those days, everyone took it as a fact that the Earth was in the center of the universe, and everything orbited around it. Everyone also believed that the heavens and everything in them were perfect, unchanging, and unblemished. The civil and religious authorities were highly invested in this view of the world and of the heavens, and they would not tolerate anyone who tried to convince others that this was not the case.
So Galileo was astounded when he viewed the sun through his telescope. It has spots that came and went. It wasn't unblemished and unchanging. When he viewed Venus, he saw that it went through phases just like the moon. The moon had mountains and craters. And when he turned his telescope to Jupiter, he saw it had several moons that orbited around it, not the Earth. What could this all mean?
Well, Galileo had shown that much of what everyone thought they knew about the heavens with certainty wasn't true. The Earth was not the center of the universe, and heavenly bodies were changeable. This was tremendously exciting. Yet when Galileo went to share his discoveries with the civil and religious authorities, they were furious and unbelieving. And when Galileo invited them to see these amazing sights firsthand through his telescope, they refused to look. They went so far as to arrest Galileo and put him on trial. He was ultimately convicted of heresy and forced to recant his revolutionary claims, and he spent the rest of his life under house arrest.
In fact, Galileo was not the only one to make tremendous efforts and sacrifice to advance our understanding of the universe. Nicholas Copernicus proposed the well-known heliocentric model where the sun, not the earth, is at the center of the solar system. He had his book banned by the church after his death. Giordano Bruno, another Italian astronomer, was burned at the stake because he believed the stars were just distant suns surrounded by their own planets, and that our solar system was not special. While many of these astronomical theories seem obvious to us now, it is important to remember that astronomy has come a long way from serving specific religions to becoming a rigorous scientific discipline. And remember, what we know today may not be what we know tomorrow.
Awesome. All right. So while we think about that story, now many of us have probably looked through a telescope. Hopefully you've had a chance to look through a telescope, and you wonder, sometimes these things you look at like Mars or Jupiter, they're just little bitty guys. And so you wish you had more magnification, that you could zoom in really close and have things look big and huge. And Jose is going to tell us about the myth of higher magnification. Jose.
All right. Good evening, everybody. I am Jose, and I am coming to you from Moreno Valley, California. I am in my observatory in my backyard. And tonight I am going to talk to you about that myth about high-powered telescopes for a low price. All right, so here we go. I'm going to share my presentation, excuse me, and many of you might have come across this image right here. 675 times the power. And then they show you this excited girl with a flimsy telescope, beautiful images of the pillars of creation and the galaxy and even the nebula. And they tell you, yeah, it's a stem, so in the package, it must be good. Well, guess what? No, it isn't.
Jose.
Yes.
I think we're not seeing the correct slides set up. We're seeing like 2 slides at a time.
Okay.
Yeah, this is the presenter's view.
Okay, well, let me go back here again and share the other one. Let me see if this is the one. Okay. Sorry about that.
It's at the bottom right corner. There you go.
Okay, how about now?
We're waiting.
Click again, maybe.
Nothing's happening.
Nothing's happening. Well, okay. Resume the slideshow here. Let me see. Really? You're gonna do that to me now?
Or we could view the slides this way. I think it's big enough.
Okay, well, let me try again on this one. Okay, wow. Do we see anything now?
There we go. That looks good.
All right. So then again, I'll say that you go to a store, you see this box, and it shows you these beautiful images of galaxies, nebulae, and even pillars of creation. Well, guess what? It's not going to happen. That is an offer that is good to be true. As you will see in the next few slides, plenty of people have no scrupulous and they will tell you that you'll go home with this telescope and it actually will show you things that you crave. Well, it's not. When you buy a cheap telescope, and please keep in mind, I'm saying cheap. It's not the same as a low budget telescope. A cheap telescope will tell you that it has so many 100 times the power of magnification. And you have to realize that magnification optics, just like everything else in life, has limitations, which means you can throw at it as much power in magnifying an image as you can, but you're gonna come to a threshold point where you're gonna hurt that view more than you're gonna make it better. So let's go to the other one. You walk through the halls of Target or Big Five, and you see that box, and you go home, you buy it, you go home, and you set up that telescope, and you expect to see this. Well, actually, no, you won't. You will not see it, and I will show you a comparison of a live view versus an image, and then a high power image and a low power image through the same telescope. So let's talk about magnification. So magnification is how many times you amplify a view. All right. So an example of magnification could be a microscope. So when you were in school, you use a microscope and you magnify, you amplify the view of a micro object or insect. Well, the same goes with the telescope. John was talking about how somebody in the beginning put two lenses together and he was surprised what he could see. Back then, it was amazing. Nowadays, if you look through one of those, you will be disappointed. You'll walk away from this hobby. You will not get interested because what you will see with a cheap telescope is not what you expect. For example, we'll see here in this graph the formula to calculate how much can you magnify an object without hurting the view. Okay, and the bigger the glass or the objective lens, the better the views or more magnification that you are going to be able to get without hurting the view. Okay, if you have a big uh, glass or a big reflector or a big objective lens, and you put a lot of a magnification, which is given by the eyepiece, you can hurt that view just as much as if you have a small objective lens than you had with an expensive telescope. All right. So these are images that you can use to compare. These are images of M42, the Orion's Nebula. These are the sword, the center area of the sword in Orion's Nebula. And you can see on this area here that it's like completely white. And you can see here that you see more space. You see the center area here all blown. And you wonder why. Well, because there's some baby stars there that tend to be pretty bright. But that is not the subject. Now, if you look to the left over here, this is an image that I took with a telescope that I'm going to show you pretty soon. This is an image I took with a cheap telescope because when I started doing this, I started buying junk stuff at yard sales. So I thought that I had this nice telescope for $25 and I would see the beginning of times. Well, no. This image on the right is using the same size of telescope, not the same one, the same size telescope, but a little bit better quality. So this is bad versus better. Not even the best, but better than the other one. All right. Now, you see this guy over here? Well, this used to be me. I used to have a room. My family room was like a telescope museum. Half of it was garbage. Bargains that I found at garage sales and Craigslist. Eventually, I learned if you want to have good views, you need to invest a little bit. So I held back a little bit on buying junk And then I say, okay, let me buy a better telescope. All right. How would you know if a telescope is good? This right here, what you're doing, you're watching us, you're listening to us, you're listening to our experiences, are gonna help you picking up a good low budget telescope. If you don't have, like, I don't know, maybe a couple $1 billion in your bank account, you know, like Elon Musk or Jeff Bezos, and you're broke like me, then you listen to the experts and say, hey, you know, I went through that. I would wait a little bit more and get me a low budget, which you can actually get a low budget telescope of good quality. You don't even have to spend a lot of money. You can buy a pair of binoculars and you will be amazed at the views that you can get of the cosmos. Now, before I turn it over, I want to show you something, because I have that same object that you just saw, M42, and you can see it right here. I don't know if you guys are seeing that's a live view of the Orion's Nebula. Can you see it?
We see stars.
All right, excellent. So while you guys see stars and while you listen to me, I want to tell you about something. You can have a telescope that will help you to see an object. You can have a telescope that can help you resolve that view. And resolving is actually being able to determine and see detail on the object that you're seeing. Now, hopefully you can see that 15-second image of the Orion's Nebula coming to you. I just took that live, okay? And now that's something that you also dots, little dots here, little dot there. And when you look at that through a regular telescope, please don't expect to see colors. Don't expect to see all that beautiful thing. That is the magic of technology through the camera lenses. You are going to see those in total gray color, just gray, no color at all, just gray color. And with that, I think that I share back. I'm sorry for taking so much time from you guys, and thank you. Have a good night.
And thank you, Jose. So I guess you get what you pay for. Cheap telescope, lots of power. You'd probably not be very happy. Okay, so with that, I think we have more questions, Sinan.
Yes, we have more questions for the audience. So the trivia question number 2 for tonight, and I always wondered about this myself, even when I was in college, was the astrobelt once a planet? Think about that. If you already know the answer, well, try to answer the next one. How did the astrobelt form? So pick one of those, type in the chat, and later we will have Cheryl to share the answer with us.
Awesome. Now, you may recall earlier tonight when I was showing you the constellation of Leo the Lion along the ecliptic or the zodiac. And I pointed out one little area right behind Leo where we were going to go deep back and show things far, far away. And that's what Manny's going to do with us right now.
All right. So can everybody, oh boy, I got to get the right thing here. Stand by. Okay. Hi, everybody. My name is Manny Lines, and I'm coming to you from Chino Hills, California. If you've been with us before, you know that I'm often at my observatory up in Mariposa, but not today. What's going on? Stand by. Let's try it again. Okay, that's better. That's not better. What is happening? Just a second here. Okay, forget that. Okay, so we've been talking about the early days of astronomy, and we've been talking about misconceptions about the Earth being the center of the solar system, well, and the center of the universe. Well, I'm going to take us a little further out yet. So is the Milky Way the whole universe. So here's a nice picture. This is from the hill where my observatory lies in Mariposa, California. And here's a wonderful picture of the Milky Way with a little meteor there. And this is what you will see, not quite this rich, but if you go out to a dark site and you look up, this is what you will see, is this immense cloud over the arching above your head. And at one time we thought that that was the entire universe. And the nature of these clouds was really not understood at all. So with the advent of the telescope, we've talked earlier about telescopes coming of age in the 1600s. Well, fast forward about a couple of hundred years into the mid 1800s, and there's this gentleman here, William Parsons, 3rd Earl of Rosse, and you may have heard his name earlier tonight when we were talking about planetary nebulae. Well, William Parsons had a truly gigantic telescope. I just put a tiny postage stamp of it here, but this is 72 inches in diameter, and you can't really see it, but the people look tiny in this picture. This is like, it's really enormous. And so this was before cameras were really very good. And so the way you took pictures, quote unquote, is by making sketches. And so here are a couple of sketches that he made at the telescope, and these were called a spiral nebulae. So a nebula being a cloud, and a spiral is obvious from these shapes that he was really able to see these spiral structures. And so for about the next, I don't know, 70 years or so, this is what we were pondering, is what are these shapes? But this was before there were good cameras, and the telescopes were yet still not quite good enough. And so progress had to wait until the early 1900s. And this man right here, Edwin Hubble, began using a telescope that is on top of Mount Wilson here in Southern California. And this is a 100-inch diameter mirror on this. It's called the Hooker telescope in Southern California on top of Mount Wilson. And he was fortunate enough to be one of the first people to be able to use that telescope to look at these spiral nebulae. And so he focused in particular on this spiral nebula here, which was called the Andromeda Nebula. And so here is an actual photograph from 1923 that he took at the telescope. And I don't know if you could see it, but there's a little tiny exclamation point and the word VAR, V-A-R, which stands for variable. And so what he had discovered is variable stars in this spiral nebula. In fact, he determined that this was not gas, in fact, but primarily groupings of stars. And these spiral nebulae had these variable stars called Cepheid variables. And without getting into too much detail, these stars were so-called standard candles that were able to be used to determine the distance. So if you knew how bright the star was and you knew it was a Cepheid variable, you could figure out approximately how far the star was away. And when he did the calculations, he discovered that the Milky Way, the Andromeda spiral nebula was in fact 2.5 million light years away. So light from the Andromeda spiral nebula takes 2.5 million years to get to us. And in fact, if you know the Milky Way galaxy, about 100,000 light years across. So the Andromeda spiral nebula, we might call it today the Andromeda galaxy, is 25 times further away. And it is one of the galaxies that is in what we call the local group. So Edwin Hubble, that name probably sounds very familiar. Usually when you say Hubble, the words space telescope come after it. And of course, the Hubble Space Telescope was named in honor of Edwin Hubble, who expanded our knowledge of the universe and the dimensions of the universe dramatically. So, but I've been talking a long time, and I promised I was going to show you a live view of the sky. And so this is the little rig that I'm using. This is right behind me here in Chino Hills. I'm actually not in Iceland or somewhere that has the Northern Lights right now. So I have this little telescope behind me, and then a camera on the back of it. And then this little mount here is being used to track the stars. So let's go without further ado, and let's take a look. I'm going to clear this view here and give you a live view. So my camera is right now taking 15-second exposures of the of a little group here, and we're almost done. There. Let me do a quick adjustment. Okay. Now, if you see these three little smudges here, these are not, well, you might call them spiral nebulae, but we would know them as galaxies. And you heard John talk about the constellation Leo. This is, in fact, within the constellation Leo, just below the stars that are prominent in that constellation. But these are actually three individual galaxies. Now, I neglected to say that the Andromeda galaxy has about 1 trillion stars in it, about the same as our Milky Way. So when you look at the Andromeda galaxy, and by the way, the reason I'm not showing you the Andromeda galaxy tonight is because I think it is just set in the west. It is now below the horizon, or very nearly so. And so I chose this group of three, very nice tight group of galaxies that are affectionately known as the Leo triplet, or I like to call them the Leo trio, because it kind of rhymes. And so these three here, this is Messier 65, excuse me, Messier 65, Messier 66, and this one over here has the very descriptive name of NGC 3628. NGC stands for New General Catalog. So these three galaxies, imagine that there are as many stars in this little group here as there are in our entire night sky, in the entire Milky Way. Now, these galaxies are roughly 31 to 35 million light years away, so over 10 times further away than the Andromeda galaxy. But these are still relatively close to us. We have imaged galaxies that are literally hundreds of millions to billions of light years away. Now, I'm going to show you, this is my little telescope view, and we've now stacked a few frames, and let me adjust the view. There. So this has decreased the background a little bit. And so you can see here that this galaxy here appears to be almost on edge. And you can almost see there's a little tail coming away. And I'm going to show you a better picture here in a moment. But these here are spiral galaxies, very nice spirals. This one's probably a spiral too, but we're looking at it edge on. So it looks quite a bit more elongated. But let me go back to my presentation really quick. And I will, oops, wrong way. Okay. Now I've done it. I've gone to the first slide. Okay. So here is the Leo trio. So if you look at this here, this looks kind of like the image I just showed you, a little bit prettier picture and turned on its side. But here are some close-up views of these three galaxies. So here you have M65 and M66 and NGC 3628, which I love this term. They call it the hamburger galaxy. So if anybody's getting hungry, there's your hamburger. Now, you'll probably notice something very odd here. It is this trail of stars. Well, as it happens, these two galaxies, and probably all three of them, have interacted in the distant past. And actually, these two have had a collision where the two galaxies literally went through each other. And as this happened, the gravitational pull literally stripped away this trail of stars here, and you can see that the hamburger got affected. It looks kind of like a wobbly wheel here, and then M66 here also you can see a bit of this tail coming off of the the galaxy as well. So that is probably an artifact of this collision between these two galaxies. So one more last time before I say goodbye, here we have a live view, and this is a little bit of a tracking error on my telescope, but here you can see the Hamburger, Messier 65, and Messier 66. And I will turn it back over to you.
All right. Thank you. Thank you, Manny. Okay, so we had some questions out there about the asteroid belt, and Cheryl is going to answer them for us. Take it away, Cheryl.
All right. Hopefully you are seeing what I'm sharing there.
Yes, we are.
All right, thanks. So our level 1 question, which quite a few answered, was what was the asteroid belt once a planet? And the answer to that, basically, in the Star Wars universe, Princess Leia had to witness her own home planet of Alderaan becoming an asteroid belt courtesy of the Death Star. Something like this. But for our own solar system, was the asteroid belt once a planet? Well, no. And that's what many of you said in the chat, but almost. Our second level question was, how did the asteroid belt form? So we know gravity creates celestial bodies. It pulls material together to form stars, moons, planets, galaxies, and so on. And too little gravity or too much gravity and celestial bodies won't form. In the case of Peter Griffin here, there wasn't enough gravity to pull the objects in, so they're staying in orbit around him. A little bit more complicated that, but it's kind of a fun little thing to look at there. For the area between Mars and Jupiter, it was too much gravitational interference from Jupiter, causing that bunch of rocks to become just a bunch of rocks instead of a planet. And that's seen here in this artist rendition. The math and physics is just right to actually have a planet there, but Jupiter, like somebody mentioned in the chat, Jupiter's a bully. Jupiter has massive gravity, and it seems to have torn apart any type of material that was trying to form in that location. So the billions of little asteroids there never did form into a planet. And the gravitational forces of our solar system have kept them as bits of rock and dust. Even if the asteroid belt was from a planet, the planet would have actually been quite small. Ceres is our largest asteroid in the belt, and it makes up estimate about 1/3 of the belt's mass. If you added all of the other asteroid material onto Ceres, you'd still have less mass than our own moon. So here's a little picture of Ceres, and you can get the size comparison of Earth and the moon. They're estimating going to be about 26 times less massive than our moon. So great job to everybody who knew the answer. There were several of you. And back to you, John and Zunan.
All right, thank you, Cheryl. And now it is getting pretty late. I'm sorry we're keeping you guys up so long. So we're going to wrap this up. Sunan, you want to talk about anything in particular before we talk about next month and the raffle and such?
Yes, so I would like to point everyone to our Facebook page, which you can see right here. So we are going to post any scheduled events on here, or if you just simply want to stay tuned, feel free to like us or follow us at Astro UCR, and that's the easiest way to follow us. And of course, later when you fill out the survey form, you will also have an option to sign up for our email list. John, would you like to have a plug for the RAS?
Yeah, just so if you're still watching us tonight, then chances are you're interested in astronomy. So I would suggest you think about joining an astronomy club. They're all over the place. I'm a little biased towards the Riverside Astronomical Society if you're here in Southern California, but there are astronomical societies, I'm sure, no matter where you are in this world, you look them up, and it'd be a good way to kind of learn more about the science and have your questions answered and such. So check out your local astronomy club.
Yes, and now it's exciting moment. We are going to do our raffle. All right, so I am posting the raffle link in the chat, and you can directly go in there. All you need is just to put your name and email address. that you use to register for this event. So this time we are going to have 3 winners for this NASA calendar. Yes, so pretty. And we will contact you over email if you win. And remember, the NASA calendar is not the only thing that we're going to raffle. We are having astronomy books coming up, and in June, we are going to give out a telescope. So definitely stay tuned, and we are here with you all the time. So John, any final thoughts before we get into the next event?
No, I just want to let people know that we will be back next month. We're here every month. And this coming month, we'll be back here on May 6th, Thursday, May 6th.
Mm-hmm.
And I think we're going to be starting a little bit later. So instead of an 8 o'clock start, we'll probably start at 8:30 or so, because we have to wait for the sun to go down.
Yeah, that's right. So we will post that event as soon as we figure out what theme we would like to do. And you can also tell us what you would like to see in the survey form. So yeah, well, I would like to thank everyone again for joining us tonight. I hope you enjoy your time. As mentioned earlier, we would really appreciate your feedback on our event. And you can also sign up for our email list in the same survey. So we will be sending out the anonymous survey tomorrow via Eventbrite. All right.
Awesome.
So I guess that's it for today. Thanks everyone for joining and staying with us, and we'll see you next time.
Bye-bye and good night.
Bye.